Good day, everyone. Today we'll be looking at energy stored in an elastic material. So we know that energy stored in an elastic material, also known as E subscript E, is equals to 1 over 2 K times E square, where K is the what stiffness constant, and where our force is proportional to what extension from Hooke's law, and it can also be written as force is equals to what K times what E. So if we substitute force into this equation, we can also write the equation to be what E is equals to what 1 over 2 F what E. So now this KE is this KE here. So we left with only one E, which is this. So where we see KE, we'll substitute F. That's what we did here. So this KE, we put in F and we're left with one E. So this is another form of this equation. So now we're given a question and we're asked to find, say the force of 12 Newton extends a rubber band at what 18 centimeter. Estimates the energy stored in the rubber band. So solution to example one. Solution to example one. Solution to example one. We have that our force is equals to what? 12 what? Newton, right? And the rubber band is extended by what? That's the E is extended by what? 18 what? cm. So now you see that since we know that our force is equal to 12 Newton and the rubber band is extended by 18 cm, that we should find the energy stored in this rubber band. And anytime you talk about energy stored, you're talking about the what? The potential energy, the elastic potential energy. And if we are to do that, first of all, we'll convert this centimeter to what? Meter. So it will now be what? Divided by what? 100, which will now give us what? 0.18 what? Meters. So after that, we will now bring out this formula. This E is equals to 1 over 2 Fe, because we are already given the force and we are given the extension, and so we should find the elastic potential energy. So since you have given those two, we will now have that E as elastic potential energy is equals to what? 1 over 2 times what? The force, which is 12, times 0.18. So our final answer will be what? Our final answer, where's my calculator? We have what? 0.5 times 12 times 0.18. 1.08. This will be what? 1.08 what? Newton per what? Meter. So the Newton is gotten from the force and the meter is gotten from the extension. That's why we have the SI unit as Newton meter. So we are done with example number 1. For example number 2, they say the string has a force constant of 4,800 Newton per meter, and they say we should calculate the elastic potential energy when it is compressed by what? 2 millimeter. So the first thing is to what? Convert this 2 millimeter now to what? Meter. So we'll convert it to meter, and they say a spring force has a constant. So this 4,800 now is the constant. So they gave us the constant and they gave us the what? Extension. They did not give us force this time. So we'll use this other formula. This E is equal to 1 over 2 K E squared, not this one. Because the last time we used this one because they gave us force, but this time we'll use this other formula. So we'll now have our solution, for example 2, to be what? We'll have our solution. So our solution, for example 2, will now be what? Since K was given us what? 4,800 what? Newton per meter. And we're given our E as equals to what? 2 millimeters. So they say we should find the elastic potential energy. So we'll recall the formula. E is equals to what? 1 over 2 K what? Ke square. So if we substitute, First of all, this is in millimeters. So to convert to meter, you divide it by 1000. And you now have what? 2 times 10 raised to the power minus what? 3 meters. So now we substitute, we have 1 over 2 times k, which is 4800 times what? 2 times 10 raised to the power minus 3 square. 2 times 10 raised to the power minus 3 square. So we have this. When we punch our calculator, we have our final answer to be what? Our final answer will now be what? 9.6 times 10 raised to the power minus 3, right? Newton meters. You know how we got Newton meters? Because this one now, since this is our final answer, but let me show you how we got to the unit. Newton meter, since the constant was in Newton per meter, and extension, we squared the extension, so it was meter what? Square. So we cancel here and you cancel here. Meter here will now be left with 1. So it will now give us n times m, which is what? Newton what? Meters. So that's how we got what? Newton meters. So we are done with the question on energy stored in an elastic material.